Hi guys, in this video we're going to have a look at volume of composite solids. So basically it's carrying on from our volume of prisms, except that instead of just being a rectangle or cuboid or a triangular prism or a trapezoid or a cylinder, this composite solids just means that we've got shapes that are made up of 2 or 3 rectangles or a trapezium or a triangle, but we're still trying to work out the volume. Okay, so we're going to have a look at 4 examples of how we do some of these questions. The formula is still the same. You still need to work out the area of the cross section, okay, and times it by how long it is. So it's exactly the same idea as volume of prisms. It's just the cross sectional area here is made up of 2 or 3 or even more 2D shapes. Okay, so let's get started on the first one here. So we need to work out the area of this cross section, which is this shape here. So I'm going to split it up into different shapes. You might have already guessed it. I'm going to split it up into rectangles. Okay, like so. So let's call this one number 1. Let's call this one number 2. Ooh, I can't really put it in there. Let's call that one number 2. And then let's call this one number 3. Okay. Right, so let's work out the area of the first rectangle. Remember, the area of a rectangle is just the base times the height. So the base here, well, the top there is 1 centimetre, so the base is obviously 1 centimetre, and the height is 5. So I'm doing base times the height, so 1 times 5. Which, of course, is 5 centimetres squared. Okay, number 2. We know the height, that's 2, but I don't know the base, so I need to work that out. The whole thing is 6 centimetres. That's 1 centimetre, and if I look over here, that's 2 centimetres. So that's 1 centimetre, that's 2 centimetres. The whole thing is 6, which means the base there must be 3. Okay, so I'll put a little 3 there, but essentially it's just going to be done in my working here. So the base is 3 centimetres times by the height, which we're given there is 2. So 3 times 2 is 6, and of course its area, so 6 centimetres squared. And the third rectangle here, again it's base times height. Well, as I said a minute ago, that's 2, which means that the base is 2 centimetres, and times by the height, well the height is over here as well, which is 3, so 2 times 3 is 6 as well. Okay, but then we need to put it all together. So we've got the area of the cross section, which just be these added together. So 5 plus 6 is 11, plus 6 is 17 centimetres squared. Okay, so that's the area of the cross section, just like we did with volume of prisms. Once you know the area of the cross section, we just times it by the length. In this case, the length is 10. So to finish it off, the volume would equal 17, which is the area of the cross section, times by the length, which is 10, so it's going to be 170 centimetres. Remember, it's volume, so cubed. Okay, that's the first one. The next one looks a little bit odd, but you should be able to spot that the first shape that we can see there is a triangle. So I'm just going to split that like so, and then once you've done that, we have a triangle, and then we have a trapezium, 2 parallel sides, and obviously it's a quadrilateral. Yep, it's going to be a trapezium. So I'm going to call the triangle number 1 and the trapezium number 2. And just as before, I'm going to work out the area of the cross section and then times it by how long it is. In this case, it's 6. So the first one is the triangle. So remember, triangle is base times the height and half it. Well, the base is 3, we're given that, times the height. Let's get a ruler. Now, I don't know the height, but what I do know is the whole shape is 10 centimetres high, and I'm told that the trapezium is 4 centimetres high. So 4, I need to add 6 to get to 10, or 10 take away 4 is 6, however you want to look at it. So the height of the triangle is 6 centimetres. So base is 3 times the height, which is 6. And don't forget it's a triangle, so you must half it. So 3 times 6 is 18. And then we half it to get 9 centimetres squared. Okay, and then I can look at the trapezium. So remember, to work out the area of a trapezium, we add the parallel sides. So that's 3 and 8. So add the parallel sides. So 3 add 8 is obviously 11. We then times it by the height. The height of the trapezium is 4. So we've got 11 times 4 is 44. And then you must half it. So half of 44 is 22 centimeters squared. And obviously we need to add that together to get the actual total area of the cross section. So I'm going to have 9 plus 22, which of course is 31 centimeters squared. So to work out the volume, or to finish this off, we just do the area, which we just worked out is 31, times it by the length of the prism, which is 6, and 31 times 6. Obviously, you can, if you can't do this, you can use your little grid method, the old pocket method, or you can do it this way, or if you have a calculator, obviously you can use a calculator. So you've got 6 times 3 is 18, so 6 times 30 would be 180, 6 times 1 is 6, so 180 plus 6 is 186, and again, centimetres cubed. Okay, so you've got a calculator, obviously you can just do that. If you haven't, and you can't do what I just did, just draw a quick pocket method to do that calculation. Okay, so there's 2 done. We've got 2 more to do. Let's have a look. Okay, so I chucked this one in there just because it does trip people up. Sometimes they sort of try and think about splitting it up into triangles and rectangles, which of course you can do. It's not a problem, but the easiest one to do with when you're given, how many sides? Yep, there's a hexagon, is just if you split it down the middle, like so, you have 2 trapeziums. So again, just remember, whenever you're trying to do this, always try and break it up into 2D shapes that you know how to work the area of. So rectangles, triangles, trapeziums in this case. So I'm going to go with 2 trapeziums, and let's call this one number 1. Let's call this one number 2. So number 1. Remember, I said it a minute ago, to work out the area of trapezium, you need to do add the parallel sides. So you need to add these 2 sides. Well, this shape down here, the whole thing there is 5 centimeters. So that is 5, and if that's 2 and this is regular, that's also going to be 2 there as well. So add the parallel sides. So 2 plus 5 is obviously 7. Then we need to times it by the height. Now, the whole shape is 8, which means that the height of half of that will obviously be 4, just half the 8. So times by the 4, and again, don't forget to half it. So 2 add 5 is 7, times by 4 is 28, and then half it, we get 14 centimeters squared. And of course, you might have already guessed it, if the top half is 14 centimeters squared, the bottom half is going to be exactly the same. So well done for spotting that if you did. And just to confirm it, add the parallel sides, so 2 add 5, the height's going to be 4 because it's just half of that, and of course we half it. So yeah, both of those are going to be 14 centimeters squared, and of course to work out the total area of the cross section, you just need to add them together, which of course is 28 centimeters squared, and then to finish it off, to find out the volume, area of the cross section, which we just worked out was 28, times by how long it is, and that's times by 5. So again, you can use the pocket method or a grid, but you can just do it this way as well. 5 times 2 is 10, so 5 times 20 would be 100, and then 5 times 8 is 40, so 100 plus 40 gives you 140 centimeters cubed again, because it's volume. Okay. And the last one, this is a very good one. This does come up quite a bit when they mess about with circles or cylinders or something like that. So it's definitely a good one to have a look at and include in the video. So I need to work out the volume of what's shaded. So basically I've got a sort of cylinder going on with a cylinder in the middle cut out of it. So it's basically like a pipe, okay? And I need to work out what is the shaded bit, so what's left. When you take out the cylinder in the middle, when you take that out, what's the volume of what's left, okay? So to do this, I need to work out the volume of the big cylinder. And to do that, I need to work out the area of the cross-section. So the area of the cross-section, I'm going to do the big circle, take away the little circle. So I'm going to call it big circle first. And remember, the formula for the area of a circle is pi times the radius squared, so pi r squared. But be careful, we've been given the diameters for both of them. So the diameter for the big circle is 12, which means the radius is half of that, which is 6. So the area of the big circle will be pi times 6 squared. I'm going to leave it in terms of pi just to make things a bit easier. So 6 squared is 36, times pi is just 36 pi. Okay, so that's the area of the big circle. Now you might have guessed it, I'm going to do the small circle. Again, I've been given the diameter, but I need the radius, so I just half that to get 2. So pi times 2 squared, which is 4 pi. 2 squared is 4 times pi, 4 pi. In this case, these ones here we were adding, but this time it's missing. So instead of adding, I'm going to take it away. So I'm going to do the big circle, take away the little circle. So 36 pi minus 4 pi, which of course leaves me with 32 pi. Now once you've got the area what's shaded within the circle, so basically this outline here, we can then just times it by 7, that's absolutely fine. So 32 pi times by 7, and again we can do it the little trick way, so 7 times 3 is 21, so 7 times 30 is 210, and then 2 times 7 is 14, so you can add them together to get 224 pi. But of course, if this was a calculated job, if you get to that stage, I mean, you can obviously just use a calculator for all of this, but if you get to this stage, just do 224 times by pi. Obviously it'll come up with 224 pi, but press the SD button, and then you can round it to however the question might say. I always round to 1 decimal place, but the question might say something different, so just make sure you read that, and obviously do whatever it says. So 703.7 centimeters cubed. Okay, so hopefully that helps explain how to do some of those more tricky volume questions, guys. Thanks for watching. Cheers.